Hi, in this tutorial we are going to practice drawing chair conformations of cyclohexanes. We have a question and the question asks, draw the two chair conformation of trans-1-chloro-2-methyl cyclohexane and decide which conformer is more stable and explain why. In this question we need to generate two chair cyclohexane corresponding to trans-1-chloro-2-methyl cyclohexane. In order to start drawing chair cyclohexane, we need to follow some basic guidelines about how to draw chair cyclohexanes. So the basic guidelines is this: we need to have 4 carbon almost on the same plane, and 1 carbon should be above the plane and 1 carbon should be below the 4 carbon plane. And how do we draw the skeletal structure of chair cyclohexane? Basically, we need to draw a line and we need to replicate this line. We need to copy and paste, but the second line should be below the first line, and both lines should be slanted, oblique, and the second line should be offset a little bit towards left. Then by this way we generate the base of our cyclohexane, chair cyclohexane, which has 4 carbons for the plane of the cyclohexane, chair cyclohexane. Then 2 carbon has to be connected up with another carbon, and the other 2 carbons should be connected with the last carbon, which should be below the plane of 4 carbon. So this is how we generate chair cyclohexane. Here I generated 2 chair cyclohexanes for you, but you need to practice a little bit to get more experience how to draw. Okay, let's start drawing trans-1-chloro-2-methyl cyclohexane. In order to draw this chair cyclohexane, we have to number carbons in the ring. So we can say that this carbon is number 1, but it's up to you for you whatever number or whichever carbon you want to start. But I prefer having this carbon number 1, and the other carbon, this one connected to that one, is number 2. So let's place here a chlorine. You can start arbitrarily by either an axial or an equatorial. I prefer starting with an axial chlorine. So here we are placing a chlorine. Okay, so the next group, which is the methyl group, methyl substituent, should be on this carbon 2, but which position, axial or equatorial? So we have to decide this one. If we place it in axial position this way, let's place here. So this chlorine is facing up and this methyl group is facing down. So basically they are on the opposite faces of the 4 carbon plane. So this is definitely a trans. So for cyclohexane to be cis or trans, we have to be careful about which face our substituents are facing. If they are facing opposite faces, it means that it's a trans. If they are facing the same face, they should be cis. So this is one of the trans conformer. How about the second trans conformer? Definitely we can place in the second conformer, which we are naming as B or labeling as B. So we prefer this time our chlorine at number 1 carbon to be in a equatorial position. Let's say this is the equatorial chlorine, and then the methyl in the second carbon should be also equatorial, and I'm going to explain why it should be this. So if you look at the first substituent, which is chlorine, it's facing downward. Let's say it's facing down. And if we look at here, the methyl group is facing upward. But you can ask this question according to what criteria we are saying up or down. Don't forget, I'm going to here place other groups on the ring for the number 1 and for the number 2 carbon. So we have here an axial hydrogen, and here also an axial hydrogen. If you look at these hydrogens, these are very good references. This hydrogen is facing upward, so at the same carbon, the second group, which is chlorine, should be facing downward. So let's write here this hydrogen is facing up direction or upper direction. This chlorine should be facing down direction. And here on the second carbon, let's say this is number 1 and this is number 2. Here again we can label as number 1 and number 2 carbons. In the number 2, methyl group is upward direction, facing upward direction. Hydrogen is downward. So that's the reason why we say this is still a trans conformer. Why? Because here our methyl group is facing upward and chlorine group is facing downward, so they are facing opposite faces for the cyclohexane. Okay, then these two conformers are trans 1-chloro-2-methyl cyclohexane. The next question, or the next thing that we need to decide, which one is more stable. As a thumb rule or as a general guideline, when our groups are in equatorial positions, that conformer is going to be more stable. And if you look at here in the first conformer, we have an axial chlorine, and this axial chlorine is going to interact with axial hydrogen facing the same face. So we have 2 chlorine hydrogen 1 diaxial interaction, and at the same time the methyl at the down face is also interacting with 2 axial hydrogens which are facing downward. So I'm going to also show them with double way arrows. So here we have 2 chlorine hydrogen 1 tridiaxial interaction at the upper face and 2 methyl hydrogen 1 tridiaxial interactions at the down phase. How about the second conformer? Do we have axial interactions? Since we don't have substituent at the axial positions, we don't have any 1 tridiaxial interaction, but definitely we have another strain or another interactions, because if you look through carbon 1 and 2 or 2 and 1, definitely methyl and chlorine are in gauche interaction, which is a kind of steric strain. But it might be sometimes difficult to visualize or to realize or to see this interaction. It's better to see with 3D models. So let's look at 3D models of each or A and B. For A, both groups are in axial positions, and you can see that this methyl group is interacting with 2 up axial hydrogens, and the down chlorine or axial chlorine is interacting with the other 2 down axial hydrogens. And if we look through carbon-carbon bond for the number 1 and number 2 carbon, we have 180-degree almost dihedral angle between chlorine and methyl group. So this is an anti-conformer. If you like visualize here a Newman projection. How about for the B? Definitely we don't have any diaxial interactions, because methyl and chlorine substituents are on the equatorial positions. And the second type of interaction, if we look through carbon 1 and carbon 2 bond, definitely we have a gauche interaction. between chlorine and methyl, because the dihedral angle is 60 degree. But the steric strain, because of the gauge interaction in this conformer B, is way less than the one tridiaxial interaction in the conformer A. For that reason, we can say that conformer A has more strain, has more energy, therefore it is less stable. So which conformer is more stable? Conformer B has less strain and has less energy, and therefore it is more stable. Thank you so much for watching.